What up, athletes? Whoop, whoop. All right, welcome to 2.1. We're talking, I better autofocus lock. Let's do this. Whoop, whoop. We're talking angles of polygons. What does it say to do right here? It says classify each polygon by the number of sides. Say whether it's convex or concave. By the way, convex just means like straight. Concave means I'm going in. Regular or not regular. Regular means every side is the same length. Not regular means is they can be lengths, different side lengths. Ready, set, do this, go. All right, I'm assuming you paused it. I'm just going to put the stuff back up on here and kind of talk to you about it. I have kind of an answer key of sorts. And you'll see I put convex means straight, concave, caves in, same sides as regular. So we see this first one right here, sides are of same length and they're straight, so it's convex regular. This one caves in, so it's concave, and the sides are of different lengths, so not regular. And then this one right here, there's no caving in, so it's convex, but the sides are of different lengths, so it's not regular. A regular polygon, well, I just drew an octagon. Imagine all those sides were the same and we'd be good. A concave octagon, well, I just took one of the sides and drew it in. Like Pac-Man. And then a triangle that is not regular. This is a triangle, but all sides are of different lengths. Okay, you got some writing to do. Go ahead and take a minute. Again, I'm going to assume you're going to pause this, so I'm just going to show it and talk it through. A diagonal is just a segment that connects any two non-consecutive vertices within a polygon. So, in the case of this key, let me make sure, and where did I put my pens? Oh my goodness, I almost didn't have it. This is a diagonal. This is a diagonal, right? Okay. So just keep that in mind, because they're not consecutive. If they're consecutive, then it's just connecting dots. That's what it means. That's a side. So they're non-consecutive. All right, go ahead and pause this if you need to. Write it down, ready, set, go. Now let's talk about Theorem 7.1. Theorem 7.1 says, the sum of the interior angle measures of an insided convex polygon is n minus 2 times 180 degrees. So if you want to know what the angles add up to inside of a polygon, then we can say this one for vertices A, B, C, D, E, the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E. So in other words, add up every one of these angles, right? Every one of these angles all around, and they will equal, count the sides, 1, 2, 3, 4, 5. 5 minus 2 times 180. So 3 times 180 or 540 degrees. It just is. It works every time. Think of a triangle. It's three-sided times 180, right? So 3 minus 2 is 1. 1 times 180 is 180. That's why all triangles add up to 180 degrees. It works. By the way, sorry about this. I forgot that's there. It was Wacky Tacky Day, and I did my thing. So boom, boom. All right. Let's go ahead and look. Again, go back, pause it if you need to write that down. Let's talk about how to find these. Okay? So I'm going to write this on a card. I got to use this in class, so I don't want to mess up this page. But it says find x. So first of all, what do the angles of a 1, 2, 3, 4-sided figure add up to? Well, we know they're going to be 4 minus 2 times 180. Which 4 minus 2 is 2. What's 2 times 180? That's 360 degrees. Okay? So I know all these angles, A, B, C, and D, will add up to 360 degrees. But look, see how I see a right angle here? And a right angle at C? So I know that these are each 90, which means 90 plus 90 equals 180 degrees. So 360 minus 180 is 180 degrees. I knew that, but I just want to show you where I'm going to get this. So what do I know? I know that angles A and D should add up to 180 degrees. So I'm going to have 3x plus x equals 180 degrees. These combine to be 4x equals 180 degrees. When I divide both sides by 4, x equals, see, 4 goes in there once, goes into 18. 4 times, which is 16 leaves 2 and 0, goes in there 5. Boom. That's 4 times 45 degrees. So x equals 45 degrees. Now, it says find x. We found x. We are God. Again, pause this. I'm going to move this up here. I'm going to use a different card for the next one. We have this tiny house problem. It says find the sum of the interior angle measure. Well, this is a, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8-sided figure. So the sum of the interior angle measures, I'm going to use another note card to help us out here. Hold on. Is going to be 8 minus 2 times 180, which is 6, or 600 and 480, 1,080 degrees. Now it says find the measure of angle A. Well, this is regular. These are all the same angle measures because this is a regular polygon. So because of that, I just need to divide. Since there are 8 angles that make this up, I'm going to divide this by 8. 1,080 divided by 8 equals 135 degrees. So the measure of angle A equals 135 degrees. And again, the reason why I divided by 8 is because this is an 8-sided figure. So I divide, so that means there's 8 vertices or 8 angles. So I'm dividing by 8. Boom, again, pause this as needed. Write down what you need. We're moving on to the next side. Ready, set, go. Okay, let's scroll on down. The measure of an interior angle of a regular polygon is 140 degrees. Okay? Find in the number of sides. All right? So, we're going to let n equal the number of sides. This one's a little challenging. I'm going to tell you that right here. Okay? This is the measure of just one interior angle. So, 2 things are true. First one is this. If I take n as the number of sides, I know that n minus 2 times 180 should equal the sum of the angle measures, right? But I also know, can't I just take 140 and multiply that times the number of sides to get that? So that equals 140n. So now here's what I know. I know that 140n equals n minus 2 times 180. I'm going to distribute this. So I get 140n equals 180n minus 360. I am going to subtract 140n from each side. I like to keep this positive. I'm going to add 360. What do I get? I get that, I'm going to move this 360 over here because that's gone. I get 360 is equal to 40n. And when I divide both sides by 40, I get that n equals 9. So what do I know? If n is the number of sides, the figure has 9 sides. I know that's kind of a tough problem, but I want you to see how to work it out. It is possible. Okay, pause it as needed. I've got one more set of stuff you need to write down, which is the exterior angle sum. Now, the interior angles add up to n minus 2 times 180, but when I look at the exterior angles, so that angle made by drawing a straight line from the side out, and then that angle in between the next side and the line drawn, all the way around, when I add up all these exterior angles, they're always going to add up to 360 degrees, no matter how many sides it is. It will always add up to 360 degrees on the outside. So the sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360 degrees. Okay, pause this, write it down. We are moving on to the last problem of today. Find the value of x. Well, this is going to look like a harder problem than it really is. It just is more tedious. But at the end of the day, they've labeled every one of these angles. I know that they all add up to what? 360 by theorem 7.2. So that means, let's add them together. 2x minus 5. Check. Plus 3x plus 10. Check. Plus 6x minus 5. Check. Plus 2x. Check. Plus 5x. Check. Equals 360 degrees. So now let's combine like terms. I have 2x plus 3x is 5x plus 6x is 11x plus 2x is 13x plus 5x is 18x. So I end up with 18x, and then I have 10, and then minus 5 is 5, minus 5 again is 0, so I get 18x equals 360 degrees. When I divide both sides by 18, I get that x equals 20 degrees. And that's it for solving for x. All right, there we go. That's 2.2. Oh, wait, is that 2.2 or 2.1? I don't remember. I want to say 2.1. Yeah, that's 2.1 with that set angles and polygons. Peace out.